Hey, hey, welcome to this Global Hack Week session. I just have a very, very embarrassing thing to to say. I forgot to hit live, and I was streaming like half hour ago, so this is very embarrassing. So I am so sorry. I'm going to do all over again. I swear. I just I hope to have time to finish this. I'm so sorry for you. Uh, I even I was saying like, hey, why is nobody commenting? I just saw Wei comment, but of course he is on the stream jar, I think. So I am so sorry. Again, I don't know where my mind is. Okay, let's do this all again. Wow, I really was. Um, okay, let me take this. Remove. Oh wow! Oh my god. Gig Yoshix, hello, hello, hi. Mm, okay, first I want to say hi. Welcome to this session of Google Actions for IoT. Um, this is going to be a small session for two reasons. Why? I only had 1 hour to do this, and the second reason is all I already take 24 minutes for my stream, not streaming. Actually I was talking to nobody. I forgot to hit live, and I just realized that I was feeling kind of weird that I didn't see any comments. So no worries. I will explain all the session. So I'm just kind of worried of not ending this. Okay, Wave, give us a little more time. Thank you, Wave. Really appreciate that. Um, I'll have to no, I won't rush, but I will do this quickly. I swear. Um, Again, thanks for being here. We are going to start right now. I just want to make some clarifications before we start. First, about the name Google Actions for IoT. My main idea in this session was to give a session about how to create actions on Google, like to communicate with a Google Assistant and ask them for do something in the real world, like, hey, Google, hope my Google Home doesn't hear me, but hey, Google, turn off the cafeteria or turn on the Christmas tree lights, whatever, right? How you can do this? Well, you can buy these smart plugs, whatever, but you can do it with a developer board. This is a ISP32. This is the AdaptKit version 1. These are very popular. You don't need specifically this one. Actually, you can buy whatever board to connect to internet. We will see there's plenty examples. I have another one here. This is an Arduino maker of the 1000 series. They recently released an Arduino Nano ISP32, I think it's called. Well, there are plenty boards for doing this. But what happened? Google is making a lot of changes to their cloud services. I face it in the week, like they changed, they quit the Google IoT core, and it's not that easy now to make actions. It's kind of weird, right? But I promise IoT and I promised Google. So what we are going to do instead of that is to connect this board with the Firebirds. If you remember, I run sessions of Firebirds tool, the Firebirds. It's the small brother of the GCP, and we are going to take advantage of that. the project we are going to develop is to connect this with code in the Arduino IDE. Really simple. We are taking advantage of some libraries, and we are going to store the data in Firebase real-time database. Right. This is really cool for lots of examples. You can do this, for example, to connect to a motion sensor, right? So it can be as easy as a logical output, a boolean like true or false. Is it true? If it's false, detect the change and send me a notification, for example. And you can know if someone entered your room where you're not around, or if you connect it to a watering system for your plants, if you're a plant lover. I fun fact about me, I am getting into the plants world, so I currently having a lot of plants here in my apartment. So whatever I can do, um, uh, smart watering system for them. uh, Lots of possibilities. It's up to you, but let's get started, right? So let me see some of the comments. Hey, all right, just got the stream. Hi, Alberto. Hello or hola. Hola. 404. Ralph back. Hey, folks. Hey, hackers. What was the board prior to the Arduino? Oh, this one. This is called um, ISP32 DevKit. This is really popular. I think it's one of the most popular ones um for IoT projects because it's cheap, to be honest. It has a lot of general purpose input output pins, and yeah, it's quite affordable. Um, Actually, it's the one we are going to use for this project right now. Um, so yeah, let's continue. Let's share my screen. You know what how to create a project in Firebase. If you don't, so you just come here to the Firebase, not the console, the Firebase page. Oh, what? Firebase.google.com. Then go to the console. It's up here on the corner or the right corner, and then you hit here in the plus sign, just create. As simple as that. I swear. In my case, I already created a project for this, so I'm not going to create it. You click here, then you follow the next steps. Once your project is created, you will see a general page like this. I have here some direct access for these two apps, these three apps actually, but this one I don't use. Authentication, real-time database. That's the two we are going to use. So when you hit authentication for the first time, you will see sign like this, how to start, the information, etc. You just hit start and select the authentication method. I done that, and the sign in method that I choose is anonymous. What's that? Okay, you can choose to add another provider. You can use email, password, telephone, the other additional providers they have, like Facebook, Meta, GitHub, whatever. But for simplicity purposes, we are just going to use anonymous. That means every time we connect our board to this application, the connection will be a new anonymous connection, and anonymous is going to save or data, right? Uh, Really, you can add this further with more levels of security, but for again simplicity reasons, we are just going to use anonymous. So why to choose authentication at all? Because that also gives us layers of security, meaning so we know who is going to connect. If we don't a name or a mail or even a password, but we know the clients connecting to our service, right? So the other thing, it's the real-time database. When you again hit for the first time real-time database, you just need to click the start, and you have to choose the region where you want to store the data. They only have three regions. The closest to me was the US. They have one in Singapore, and they, well, I think Singapore, to be honest. I don't want to lie. But the other two, I don't know where they are, but there were no close to me. Choose the one that best fits the closest to you. And the other thing you have to choose here on the real-time database, and this one it's very important again, it's the test mode, because for default it is not choose, it is choose the other one, and you will have to add more layers of security, meaning that you will have to do more things here on programming, and we don't want that for the moment. You can again add them later, but for the moment we are really good with the just test mode. We just want to see uh, data measured in the real world, applied and uploaded here to Firebase. So that's okay for us. Okay, that's nice. So what's it? That's it. Yeah, actually, that's all we need to do here on Firebase. Now, keep in mind two things. When you create these that database, you will be thrown a URL. That URL, in my case, I don't have it. Let me see if I can find it. Oh no, I think oh no, yeah, I have it. It's something like HTTPS slash slash uh, the name of your project. In this case, it's for me it's Global Hack Week IoT. Then default RT-base, real-time database dot firebase.io.com, etc. It's something like that, but it's unique for every project and it's unique for your real-time database. If you miss it, I'm not sure where you can see it again. Let me see if we have. Hmm, no, I don't think we have a way to see it again. Oh, so it's this one. It was in front of my eyes. So sorry. It's this one just right here. So keep in mind this link. Remember where it is. Don't forget it, like me. And the second one you have to keep in mind is when you go here to the configuration of the project, of the entire project, you will see this API key. This is unique again for your project, and the truth is you won't have to share it. I'm sharing this because for educational purposes, I mean, but I'm going to delete this after the session is end, so there will be no problem here. Copy and paste this and save it somewhere because we are going to use it. And at this point, that's already we need to do with Firebase, right? So, any questions this far? I see no questions on the comments. I just see Master Gardener from Way. I hope to become. That will be cheating. All good from Way. That's cool. So then we pass to Arduino, right? The Arduino ID. And I have a code prepared here. And before taking a look to this code, we need to use or we need to add, sorry, a library to our Arduino IDE. How we are going to do that? Well, you click here on the left bar to the libraries, and you find the library manager. You search for the Firebase ISP client, and you will see this one, the Firebase Arduino client library for ISP ISP8266 and ISP32 by Mobits. This is already installed in my case, but you are going to need it to install it. Um, let's take a look here in more info. You'll be opened a new Firebase repo. This one, the Mobits Firebase ISP client, as Arduino client, it's a library for and these chips that many developer boards uses. And it's good for Firebase, supports real-time database, cloud file store, even cloud messaging on cloud functions, right? So really, really cool library. And we are going to take a look on how to use it so we can understand better this code. Should the database be in test mode or log mode? Test mode, please. That's important because if no, we are going to add more configuration here on code. Um, I recommend you to do it after the session is end, like start experimenting on your own end. But if you want to follow exactly what I am doing here, is test mode. And thanks, Wei, for answering. um, yeah. So features, supported devices, dependencies, installation. Let's start exploring the features they have, the supported devices. I have ISP32 MCU baseboard. Mine it's like that. Uh, what other Arduino Maker? This is the other one I have, like the Arduino Maker 1000 Wi-Fi boards. The Arduino Nano 33 IoT. I heard amazing things about this. I want to buy one, to be honest, but I haven't had the chance. Raspberry Pico, also really cool. Dependencies. This library requires Core's SDK to be installed. For Arduino IDE, the Discourse Bold Manager, the Expressive 32. What does that mean? That means that when you choose here the board you want to use, Arduino IDE it's cool enough to tell you like, hey, I see that the board you want me to program, I don't have the drivers for that. You want me to install them, and you just say yes. That's all you have to worry about, to be honest. Oh no, I was trying to open this. Huh. Migrate if you want to migrate from Firebase to Firebase ISP client, because these other are libraries that already existed. Here, Firebase ASP32, they are created by the same user, so it's an update for that. The installation it's simple. You just click include the managed libraries as I show you and hit install. That's all. If you want to do a manual installation, that's quite difficult. Well, not that difficult, but it's libraries. And why should we do that if already the Arduino IDE it's cool enough to do it for us? Um, hmm. The usages. Okay, for installation, the first thing you have to notice is we need to include, same as here, the Wi-Fi. When we include the Wi-Fi, this is for the ISP32. Again, check specifically for your boards. We're not using the ISP8266, or we're not including that, and in neither of those things. Then we have to include the Firebase ISP client.h, which is the one we are installing. And we have to define some things for the database connection. The first is the data object. So we define it as Firebase data. Here I have it, Firebase, sorry, data. Oh, FBDO. Then we define the Firebase authentication data for identification. So that's Firebase auth, and we defined it as auth. Then we define the Firebase configuration for the data, and that's Firebase config. Then assign the project host and API keys. So this is what I showed you before. I defined them as global variables. Um, the config.host goes to, let me see where I put it, goes to the API key. Mhm. Here, config API key, and the API key for me is this one I showed you before. Then the config.host, uh, where I put it. Oh, I think I miss it. Where am I using the database URL? Well, in my case, I'm using config.database URL. Um, no, this the ones. I'm going to close this one. Oh, not closing. Okay, doesn't matter. Okay. Huh. I'd see a comment here. Um, Raspberry Pico. Yeah, it works. Is there specific requirements for a vault to be sufficient for such purpose as is covered in this project? Actually, this is really simple. It's just reading an input and maybe writing an output. So no big requirement for this. The only requirement I would say is to have a chip that supports Wi-Fi connection. In this case, the chip we are working on, it's the ISP32, but there are lots of other more. So I recommend you to find one that has a lot of support from the community. The ISP32, it's very well supported for the community. Um, but also for the Arduino ones, they are more expensive. Like, let's say the truth, like these Arduino boards are more expensive than these other ones from Expressive. Um, but the two of them are very well documented and supported by the community. For example, where an Arduino Uno R3 or a Raspberry Pi 3 Plus work. Uh, no, the Raspberry Pi, I think. Well, for the Raspberry Pi, I'm not sure. For example, the Arduino Uno, as I was just saying, has no support for the Wi-Fi integration. So you will have to buy a Wi-Fi module for that. And the Wi-Fi module looks like. Let me see if I have a module right here. Oh, I think I lost it. Oh my. Yeah, I don't see my Wi-Fi module. Well, I lost my Wi-Fi module. I just realizing that. Yeah, no Wi-Fi module to show you. I'm so sorry, but in the end, the Wi-Fi module probably used the ISP, the ISP chip. So I recommend you to get if you have a board the module, but again, to be honest, the module it's almost the same price as the developer kit. So you can find one of these with the chip for connection to the Wi-Fi, plus the all the outputs and inputs. But very but, well. Uh, yeah, I will say cheap. So that will be my advice. Just find a one that already contains the module, the Wi-Fi connection. So, do, do. Yeah, we were doing this like the Firebase host. Firebase host is the config, the IP key, the using assigned for credentials. In our case, we are doing this anonymously. Then you can use this if you want to connect via user, email and password. And then we initialize the library authentication and the configuration, right? So in our code, we do this right here. Fiverr sign up, config and out. Uh-huh. Begin, config and out. Okay. Uh-huh. So the Firebase begin, Firebase connect Wi-Fi through. Optional set IP connection in setup. Optional set the number of error to retry. Optional, well, you will see all the things you can do. Then we can go to the memory options, talk about these things, change all of these, blah, blah, blah. Let's see what more. Memory, authentication. Well, we try about the authentication. Here they are doing with email and password. We're doing just anonymously. Uh, for example, here to use sign out anonymously enable. So we already enabled this. We created this. These documents provides the RT security rules details. What other things we can do? Library options. We can change some options here, etc., etc. So, append data, store data, blah blah blah. Okay, I think we're ready to explain now our code. Just yeah, yeah, we're ready because here we want to find the Firebase storage, cloud functions, sorting the my roles, blah blah blah. So let's return to the this. Those suggest initialization, memory options, authentication, library boot, real-time database. Return. Read data with get in, get flow, get double, blah blah blah. We write the data with set in, set float, set double, set bool, set string, set JSON, set array, set blob, set file. Right? Remember that. So we do first the import of the project. Let me choose, uh, close that before, sorry. We import the Wi-Fi font library. If we look for the Wi-Fi dot h, well, we can. search for help here. Documentation, and we will see this. This Arduino Wi-Fi shield. Oh no, this is not the shield. I don't want this. Okay, this serves as documentation. This article is a compilation about useful functions for the ISP32. Will cover options, blah blah blah. You see, there's a lot of community, and this is what I was talking about for this board. Um, you will see there's actually a lot of articles, a lot of repos, a lot of documents, a lot of resources to actually use these kind of boards. So here's a list that will be covering this tutorial: Wi-Fi model, station, access point, etc. And we can use the library. This library is created for this, and it's already in the Arduino IDE. So the first thing you need to use the ISP32 functions functionality is to include the Wi-Fi.h library in your code as follows. Uh, how to use this library? Uh, here's a tutorial of how to do this, the installation. If you prefer to use VS Code and Platformio, I've tried, and I don't know. I kind of have mixed feelings about this, the platform IO. Like, I don't know. You look cool doing it, but because you can say, "Oh, I don't use Arduino IDE. I do other stuff." Uh, but I don't know if it's worth it, to be honest. Huh. The ISP32 models. You can change the mode to Wi-Fi station, Wi-Fi A, access point, or Wi-Fi access point and station. So we don't want about this. We want to do the connection, right? Uh, mm, Let me see. Do we have an index? Connect to a Wi-Fi network, right? So to connect to a Wi-Fi network, we need to use this Wi-Fi begin using the network that we want to connect as ID and passing it to the password. We do this code that is connecting to the Wi-Fi, and while the Wi-Fi status it's not connected, we are going to print a dot. Then we can print the local IP of the network, and that will be it. The SSID and password variables hold the SSID password and the network that you want to connect to. And that's all, right? It's simple. Um, this connection Wi-Fi connection status allow us to know what's happening, and this is really useful. Actually, I was looking for this because when I do this the first time, um, I was getting a lot of ones when I printed the Wi-Fi status, and I don't know what that is. So easily we can change the while L connected to the value of 3, and now will be the same, right? Kind of. Uh, but yeah, then we can return to our Arduino code, right? So the main thing we're doing here is creating this connect. Well, including this library, we include the library for the ISP clients, and we also include two add-ons, which are the token helper and the real-time database helper. Right. So keep in mind that. What was that? You see the balloons? I kind of see balloons here on my screen, but I don't know. uh, okay, then we define some variables. My Wi-Fi SSID, it's called Red Insegura. That's for terrorizing my my well, the people who lives in the same building that I do. But I will change it to share the network from my cell phone, right? So um, I will do this personal hotspot. The name of this will be iPhone de Alberto, I think. Yeah, I think. Let me check here. Yeah, it's iPhone de Alberto. Oh, I don't know if that's an. Okay, that's interesting. I don't know if it's an exclamation mark or an I, but we'll find out. And the password is um, por favor. Then my IP key, it's just defined. Remember, we know how to get this from Firebase. Then my database URL, it's this one for making the connection. Where here we need the database URL for making the connection. Um, well, trust me, it's somewhere around here. Yeah, it's somewhere around there. Then we define just the pins of where we want to do the lecture, the pins of the. I was planning to use an LDR, but I got no model for that. Instead of that, I am using one of these. This other module that it's a light sensor. Kind of detects when one of these LEDs emits the light and the other one receive it. So it tells you like the distance from how much time does it takes to receive the emitted signal, right? It's quite simple. It's an Arduino module. If you want to check it out. Uh, I'm sorry, wait. I'm going to put more speed on this. Then we define the things we have to define. We know what this Firebase data is. We know what this Firebase out is. We know what this Firebase config is because we check the documentation, right? So another things useful for this it will be ascend data pre meals. This will help us to set the interval of time in which we want to send the data to the real-time database. So we will not be sending it every single second or every single millisecond. It will be every 5 seconds. To sign up, it's okay. The LDR data and the voltage. This will be just fine. Then we serial begin the connection with this baud rate. Then we Wi-Fi begin. We pass the Wi-Fi SSID. We pass the Wi-Fi password, and then we serial print connecting to the Wi-Fi. If these Wi-Fi connection is not done, we are going to delay this until the board connects to internet, right? Because it's essential. Then we print the successful connection to this IP. We print the IP, and then a new line. Um, then we set the IP key, the database URL, and if the Firebase hanged up, it's okay. We just say hanged up, okay. We set this hanged up, okay, to true. Else, we print the error message for the signed up, right? Then the token status callback we share, we save it to the config, and the Firebase begin, set the config and the authorization. Then we try to reconnect to the Wi-Fi. If Firebase is ready, if the signed up is okay, and the time comes to send messages, to send the data, because that always will be time to send the data. Remember, we just want to send it every 5 seconds or 5,000 milliseconds. We'd send the data to milliseconds. We do an analog read of this pin we declared before. We store that data, and then since these analog rig give us values of millivoltages. We want to declare this voltage to as a float of analog reading voltage lecture. So we install that in the voltage, and now we do this all very similar codes. First, for the real-time database set integer of the LDR data, and then for the set the voltage, right? So we just create the path to the database. If it doesn't exist, it will create it. Don't worry, but be careful because you might be wanting to save for the same, let's say, path. And if you miswrite something, you put a capital letter, you put an extra space or something, you will create a whole new bunch of data sets. And you probably won't want it, right? So that's it. We print in the monitor the output, but also we set the the data to the real-time database. If there's a problem, we tell it failed, and that's the reason for this failure. And that's actually it. It's a really simple code once you understand the library we were using, which are the Firebase ISP client one and the Wi-Fi one. So let me connect my board and let me run this. Okay, connected. You see the red dot over here. I'm going to upload this to the board. It's compiling, so let me know while this compiles. If you have any question this far, we are really close to achieve what I thought we wouldn't have time to achieve. Uh, yeah, let me know. I'm curious about if you're liking this, you are understanding what I'm telling. Um, you are thinking, oh my god, this is so boring. Let's just go to the Y session right now. Takes its time to compile, to be honest. Huh. Come on, come on, come on, come on. Meanwhile, it is compiled. Forgive me a second. I'll be just back. Cool. I'm back. So, come on. You can do it. Oh, now it's uploading to the board. That's cool. It was compiling. Let me open in the tools the serial monitor. Hmm. Again, tools, serial monitor. Okay. I think we have a problem here because okay, this this one serial print dot, then Wi-Fi status, and this is where we take advantage of this one here. No SSID available. Why is that? I mean, if I click here on the Wi-Fi, you will see iPhone de Alberto. So I'm guessing I didn't write it here. Code 1, right? Value 1 when no SSID are available. Hmm. Let me try with another one, which is red. Okay, I'll check. Can I connect this via an IP? Maybe because I'm not doing this const char. No, but I'm doing as a define, so it will be. just fine. Why is that? Hmm, 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 hmm. So, yeah, I will try with my other network. And the password it's this one. So I think we will have to upload this again. Whew. That's it, right? Hardware. Let me see some comments. Hello, MLH community members and audience attendees. How are you? What is the session plan? Okay, we're almost ready to finish the session. I just wanted to make the connection for you to get this code right. Um, but yeah, what we done in this session is to create a Firebase project, including authentication and real-time database apps, so we can connect with an IoT device. In this case, it's a developer kit of ISP32 version 1, and store the data from a sensor. In my case, it's going to be an analog reader of distance using infrared light. Uh, so yeah, that's it. We explore that. We explore the libraries for the ISP to the client Firebase made by the community, um, and that's it. Can you please share the reference resource link in the discussion window? Yeah. Um, well, the if you just look for Firebase ISP 32 on GitHub, you can see the library I was talking about. This one for Mobits is the first. I think it's the most popular one, and it's really cool. So yeah, let me share the link with you. Oh no, but this is Firebase ESP32. This is deprecated. We need the one for both. Well, if I hit here on the Mavits, well, I think this is, yeah, Firebase ISP client, and this is included for all the, yeah, for all the chips. So here's the link. There is the repo. The Can you check the check-in link? Oh, thanks, Wei. You already uh, share it. You're so nice. So please don't forget to check into this. Yeah, I think that's it. So let's see how our compilation it's doing. Okay, amazing. It's already uploading. So what the serial monitor says? 6 6 1 1 again? Why do have? Well, we have the six. You saw. What does the six mean? Disconnected from a network? No SSID available? Why you're telling me no SSID available? Like, yeah, I'm connected to it. Okay. Um, Let me look here if we're missing something to make the connection. Connect to Wi-Fi. Maybe the mode. I'm well. Why not? Let's try it. Wi-Fi begin. Before the Wi-Fi begin, we have to change the Wi-Fi mode to Wi-Fi ST8. I can scan Wi-Fi networks. Oh, that's cool. We can use this code. Wi-Fi scan networks will return a number of networks found. Okay, I am going to copy this whole code. I am creating a new file, and I am pasting this. I am just going to interrupt the previous connection, connect it again. Let's see why we can't connect to the network. How many times your session got pushed away? I really don't want to take out your time. Um, I mean, this code works. I've tested before, so right now it's just problem the board connecting the network. So I think I'm good to end this session. Uh, but just let me know. 4:30. No, I that 9 minutes works perfect. Thanks. It's already uploading. Huh. No, thank you. Okay, let's see. I have infinitum. Yeah, I don't see. Yeah, actually. There's no, maybe because of the, yeah, I see it's only 2.4. Okay, I think this is mine too. This one, like, if you connect hack you, that's mine. So let's change it, and let me get the password for that. Please don't share it. I'm kidding. I know you won't share it. And the password for this it's niditobodet 001. So that should be it. We already scanned the networks. Now we should be able to connect. Let's do this. Wow. Once this compile. Uh, so yeah, I was thinking of more examples of projects you can do with this. Like for example, did you know that the light actually takes a big place in the studying habit? Like if you try to study in some place that it's not well uh, bright and that it's dark, etc., you probably will have problems to concentrate. So you can measure that. You can buy a measure of lumens, or I don't know how it's called in English, but yeah, you can measure the quality of light for your desktop and everything. Then run analytics on that, because of course you all have all the data on your real-time database on Firebase. And then like run predictions of what's the best time of the day for you to study, or if at some specific times you will have to improve your lamp or your light bulb on the room, or etc. You know, um, what other projects you can do? You can do, wow, whatever your imagination tells you. Like, actually, um, did you know this cool page Hack Stereo? Like they have amazing builds all the time. And there's another one with these the mascot. It's yellow robot. I can't remember the name. If someone knows the name, yeah. What was the name of this page? No, sorry, I don't remember. But you can find inspiration there too for the projects. It's really cool. Um, what was the last project I built? This was for school. That actually this was not me wanted to do this stuff, but the last project I built was on with two boards. Do one for reading infrared light from a control, and then connection between the two boards with um, radio frequency signs, and then I use an H bridge to uh, just put start motors running, and yeah, I connected the motors to a band, and what was the other thing? Like a Ferris wheel. 0 0 connected. Amazing. The sign up. It's okay. We successfully saved data now to our database in real-time database. Oh, I'm so excited for this. Now, why don't we go to our Firebase panel uh, that is in here, and go to the real-time database and see what we are saving. I'm going to give you a little spoiler. This is not connected to anything, so the value should be 0. Uh, but let's see what we're storing. Meanwhile, this loads. I'm going to connect this to see if that changes. Oh, you see, we have now created this document called sensor, and we are storing the LRD data, which is zero because we're not reading anything, and the voltage is nearly zero. Now let me connect this to, we say, what we choose, what pin we choose. Choose pin 13. So pin 13, and I am going to connect this like this. And the measure voltage should change in just a couple of seconds. Let's see. Let me see the serial monitor. Successfully saved. No, I think then it's now the pin 13. Or is it? The voltage, it's been saved. Oh no, this one's not. Don't save. This was just for checking out the networks. This. Uh-huh. Okay, we're still getting this signal, but I think it's for the LED. Well, the thing here, let me see if I can share. No, well, for the background, you won't able to see it. But I have this now connected to a board, and I'm just making sure that the signal receives more than 13 millivolts. Uh, I connected directly to the 5 volts. No, I can connect it directly to ground to see if that's changed to zero absolute. Every 5 seconds it's supposed to send. So now, then now, then now. Now, okay. The important thing here are not the schematic of the circuit because I'm doing wrong. I just wanted to see how easy it's to make this connection. Now you can take care of debugging the actual circuit to get the correct read. But we're getting something. It is not the correct read. We're getting this information from the IoT board. This is not connected to my computer. This is not connected to anything, but it's connected to the Wi-Fi. Now the Wi-Fi, via the Wi-Fi, it sends the information via yeah, it is an anonymous, but it's an authorized service from Firebase, uh, and we are receiving it here, and we can see our database updated. So I am really excited to have completed this, and on time because Way's session it's about just to start. Thank you, Way, for being here. Thank you for being so cool. Thank you for letting me some of your time, and thank you all of you 404, Tintin, and all the amazing other hackers that have joined us. Ralphak, Green Joshix, and Rashler, and yeah, that was amazing. If you have any questions about how you can continue these or how you can do it the other way, read something from the database like an action or something, and just send that to convert this little board into a smart plug because it is simple. You just have now to connect it to a relay module, something like I have one here actually. This is a relay module, so I just need to connect this to the board, and I have two outputs to turn on and turn off my lights. And I'm not from home, even if I am from anywhere in the world. Um, you don't need to buy Philips Hue. You don't need to buy a smart plug from Amazon or something. You can do it very hacky, right? And you can implement it in your next hackathon. And you see, it's not that complicated, right? So let's make things simpler. Um, Thank you for the session. It was fun to finally get it connected. Yeah, it was really cool. Thank you, thank you. I'm going to say goodbye. I appreciate that your time and all your love. See you in future global hack weeks. Bye bye.